Hello, welcome back to Cracking the Cryptic. Today we've had a couple of viewer requests which we really enjoy actually, so do keep them coming. You can reach us on either our Twitter account, which is @crypticcracking, or our Gmail account, which is crackingthecryptic@gmail.com. So I don't know how hard this puzzle is going to be. I suspect quite tricky, but let's take a look at it and see what we can see. Put a 6 in there. That's fairly straightforward. As usual, if I manage to identify in a 3x3 block exactly two positions where a number can go, then I will put in some small notation marks just so that I can remind myself of that fact as we go through the solve. Now, what next? 9. Some 9s in here. The way I'm getting that is this 9 here is eliminating 9s from these two cells. So I know there's a 9 in one of these three positions. Therefore the 9 in this 3x3 block must be in the row 2. And we have a 9 here. So again I can make some pencil marks and move forward. This has to be a 6. And there's another little trick we can do there. You can see in this 3x3 block and this 3x3 block, I've managed to lock the 6s into rows 7 or 8. I don't know where they're going to go, but I know that they're in rows 7 or 8. So if we look over here, it's impossible to have a 6 in row 7 or 8 in this block as well. If we did, we'd have repeated 6s in a row. So I know the 6 in this 3x3 block must be in row 9, and we have a 6 here. So this cell must be a 6. We can add that in. So a 3 in one of those two positions. Let's see how that's going to particularly help me. This cell's restricted because look, we've got 6, 7, 8 in the column here, and so the options for this actually are 2 and 5 in the cage as well. So this could be a 1, can't be a 1, 2, can't be a 3, can be a 4. Can't be a 5, can't be a 6, can't be a 7, can't be an 8, and can't be a 9. This cell has to be a 4. This is called a hidden single, and it can be very difficult to see these, and I think this is where practice comes into the puzzles a lot. If you're used to spotting that sort of thing, it's a real advantage. And I can notice something else off the back of this. If we look at column 2, you can see that we have a 4 and an 8 in the column. If we look at row 4, we have a 4 and an 8 in the row. So let's think about how they interact in this block. And you can see that we can't have a 4 or 8 here, 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 or here. So there are only two positions left where the 4 and the 8 can go, and that's those two positions. And that may be useful. Let's see. So now I can pencil mark some 1s up here. I can pencil mark 1s over there as a result of that. There must be something more I can do with that, I would have thought. I feel like I'm being slow and not seeing what's staring me in the face. Now I can't see how to make more progress with this block. See if yeah, we can add a pencil mark here, but with the 4s. This 4 and this 4 interact to force the 4s into row 8 here, and that gives us a 4 there. That's got to be a 4. Let's put that in. 4, 4. Right, okay, yeah, we can do something else here. If we look at this 3x3 block, you can see we've already got the numbers 3 and 6 placed. And if you look at row 1, we have the numbers 1, 4 and 9. Now, something just to be aware of, again, this is just practice. If we look in column 5, we have the numbers 1, 4 and 9. So I know that the numbers 1, 4 and 9, in terms of this 3x3 block, don't go here, here, here or here. So they have to go in the only 3 other positions. So we have a 1, 4, 9 triple in these squares. Now we have a 4 here, so I can eliminate the 4. I don't think... I can't go further than that. But this sort of thing is helpful. I definitely need to try and use this to make progress. You can see immediately this 2 here, now that 2 can't go in any of these 3 positions either, it forces a 2 into the top row, forces a 2 into one of these 2 positions. 9, 7. Again, I feel that there's something I'm just not quite spotting here. Well, I guess this 9 is interacting with this cell. We know there's a 9 in one of these 3 positions, so this isn't a 9. So what do we need? 2, 5, 7 and 8 into... I'm just going to notate that's a 7-8 pair, just in case it rings a bell with me. I know it's not strictly the notation I'm recommending, but with these harder puzzles sometimes we do need to be flexible. 2, 5, 7 and 8. So 2, so this is 5, 7, 8. Aha! Look at the 3 here. So the 3 means we can pencil mark 3s into those 2 positions. We can pencil mark 3s there, but more importantly, what can these 2 cells be now? So if we look, we've already got a 1, 2, 4, 6 and 9. Add a 3 to that, and the only numbers left, I think, are 5, 7 and 8, which matches here. So I've got a 5, 7, 8 triple in column 8 now. Now, this 8 here means we can eliminate one of those possibilities, but that means this can't be a 7. I can remove this 7 and place a 7 into this cell. What else is left in this? 2, 4, 9. I thought there might be more mileage to be made from this 5, 7, 8 triple, but this is quite an interesting puzzle actually. I think this is a difficult puzzle. Already the things I've had to spot are unusual. Well, this cell can't be a 3. So where can I place a 3 in row 4? This 3 means it can't be in these 3 positions, so it must be here. So that gives us one more number. Oops, 2, 3 here. 3, 3. 3. So we need 1, 2, 5 and 9 in row 4 now. So this is a 2, 9 pair. Okay. Yes, and we can use the fact that we have this 5, 7, 8 triple, can't we? Because that means there isn't a 5 in this square. Therefore, where do we place a 5 in row number 4? It can't be here. It can't be here or here because of the 5s in the columns. So this square must be a 5. That means this is a 1. And we have a 2, 9 double in the rest of the row. Now let's just check whether we can do anything more with that. Yes, we can. We can get a 1 into this position. Maybe this is where the puzzle is going to become easier. 5. Or maybe not. So 3, 2, 3, 9 down. No, I don't think that's quite going to resolve things either. Okay, look, we can look at the interaction of this 8 here and this block. That means there's an 8 in one of these 3 positions, which means there's an 8 forced into those 2 cells. And that does matter here, because look at the middle block. We know that the 8s in this middle 3 by 3, we don't know where they're going, but we know that they are locked into either columns 4 or column 6. And we have the same thing here. 8's locked into column 4 and column 6. So when we come to this 3 by 3 block, the 8's cannot be in column 4 or column 6, so they are locked into those two positions. Now, does that matter? Well, it might matter. Let's have a look now again at row 1. We've got 2, 5, 7 and 8 to place, so this cell here can now only be 2 or 5. This is 2, 5 or 7. It's 2, 5. I'm just going to check the column here because I've noted this cell. Look at this cell here. Now you may look at this grid and say, why am I looking at this cell? Well, the reason I'm looking at it is there is a lot of pencil marks, or there are a lot of pencil marks having an interaction with this cell. So although we've only got a 4 and a 9 in this 3 by 3 block, I've also got pencil marked 1s, 6s, 8s and 3s all pointing at this cell. So what are the options for this cell? It can't be 1, it can be 2, can't be 3, can't be 4, can be 5, can't be 6, can't be 7, can't be 8, and can't be 9. 2, 5. So actually this is an interesting puzzle. I'm now starting to think this is a very cleverly designed puzzle. I don't know what the provenance of it is, but every step that we've had to use has been quite difficult logically and has followed very much from the last logical step. So this feels like it's been very cleverly put together. Now what can we do now? We have this 2, 5 pair in column 6. Well, not seeing much. I suppose it eliminates a 5 from this cell, so we can put a 5 into those two positions. That eliminates the 5 from there. 2, 7. Oh, wait a minute. Right. There is, or there might be, something interesting. Okay, I'm not sure this is going to work. I hate doing these things live when they get this complicated because I think it might make me look like a right Charlie. But where can we place a 5 now? In row 8. So you can see this 5, it can't go here or here. Now all this work we've just done means the 5 can't go here, and it can't go here. It can't go here because of this 5 pair, and it can't go here because we've got this 2, 5 pair that we found in column 6. So the 5 can go here. Let's just pencil it in just for the moment, and it can go here. So there are two possible positions for a 5 in row 8. Now, whenever you find this sort of thing where a number is restricted, and it seems to be restricted by design, you know, the fact that the 5 is locked into these two positions is very much a consequence of all the hard work we've had to do. So it should set your spider senses tingling. Now, can we find another row that has a similar restriction regarding where the 5s can be placed? Now, the immediate place I'm looking here is this is row 3, and that's because if you look at row 3, we can eliminate the 5 from these first 3 positions instantly because of this 5. Now, this square can take a 5, so that's corresponding to the position of the 5 in row 8, so that looks good. This cell can't contain a 5 because we have this lovely 2, 5 pair in column 6, and that's all I need to know that we've made progress. I don't care that there are, in theory, 3 open positions for a 5 in this block, and I'm going to show you why, and this is really, really sweet. So I'll add some highlighting at the end, but we have a 5 here, 5 here, 5 here, and a 5 somewhere along these three positions. And what we have here is something called a finned X-wing. And this is a lovely, lovely example, because we just need to ask ourselves the right questions now to make immediate progress with the puzzle. If you can't spot it, do pause, have a look at what we found here, have a look at the positions of these fives, and ask yourself whether you can deduce something important. And let me try and explain. So let's ask ourselves the question, what happens if this is a 5? If this is a 5, I can eliminate this 5 here, and I have a 7-8 pair. In row 1, that's going to give me some numbers here, useful numbers. So if this is a 5, it's all hunky-dory. If this is a 5, it's exactly the same. I can eliminate this 5, and I've got immediate consequences. Well, what happens if, on the other hand, this could be the 5? Now, if this could be the 5, all of a sudden we have another lovely situation that emerges, because that means that we have an X-wing on 5s. Now, what do I mean by an X-wing? Well, those of you who've watched the channel for a long time will know exactly what I mean. But in effect, it means that the 5s in rows 3 and rows 8 have only 2 possible arrangements. So in one arrangement, this will be a 5, and then going down to row 8, now this cannot be a 5 here, so the only other valid position for 5 would be here. So this would be one possible configuration of 5s in the finished solution. Note that they contained a 5 in this position. Now let's say that's not the case. If, on the other hand, this cell contained a 5, well, you can immediately see it. I mean, we don't really have to go any further. If this cell contains a 5, I can eliminate the 5 from up here. So either way round, this cell here can never contain a 5, either because we will find that the fins of the X-wing are true, in which case we'll eliminate the 5, or we'll find the X-wing itself is true, in which case we'll eliminate the 5 that way. So we're able to eliminate this 5 from this cell, and I'm hoping that will help the puzzle. So now this cell here is a 2, so it cannot be a 7, and this is a 5, which means this is a 2. And is this going to crack it open? I'm hoping so. The 2 here interacts with this 2. That allows us to place a lot of numbers. Look, we can go 2, 3, 4, 6, 9 immediately, just as the result of the pencil marks that we put in. 4, 8 into these 2 cells. 9, 2. Therefore this has to be a 9, I think. And this has to be a 3. And that all looks like it's working, doesn't it? And therefore we have a 7-8 pair into those 2 positions. We've got, this must be a 3-8 pair in this 3x3 block, and we have a 3 here now, so we can go 3 and 8. Oh, whoa, I didn't mean to do that. No, I wanted to put 3 there. 3, please. 3, okay. This has got to be an 8 now. This must be a 9. This must be a 5. And I think hopefully you'll agree, I think the puzzle is now solved. 2, 3, 4 along here. So 2s, 3s, and oops, 4s like that. 2, 3, 4 means this cannot, this has got to be the 9. Now, we knew this had to be a 1, 4, or 9, so this must now be a 1. That means that's a 4 and that's a 9. And this has got to be 7 here, I think. Because this cell is a 1. 7, 8 double up there. So this has got to be 5 and 6, which means this is a 6 and this is a 5. This is a 5, 5, 1. Yeah, 378 looks right. This cell here has to be a 1, 2 or 5, but can't be a 1 or a 5, so this must be the 2, which I think is going to fix the rest of it. So 2, 3, 4, 3, 7, 8, 5 here. This must be a 4, I think. And there we go. So a really, really interesting puzzle. Thank you very much to the gentleman who sent us this. I'm not surprised that it was a challenging puzzle. It contained quite a lot of difficult steps, and they all had to be found in order. Otherwise, well, I mean, maybe there were other ways to do this, but the way I found it very much relied on a sort of linear sequence of difficult logical steps, which is exactly the puzzles that we wanted to cover on the channel. So thank you very much for sending it to us. If you have any puzzle that you'd like to see us solve, do send it to us too. Subscribe to the channel if you enjoy the content. We really appreciate that. Thanks for watching. We'll be back soon with another edition of Cracking the Cryptic.